In this video, we are going to see about a step response of RC circuit. So, when DC source, that may be either voltage source or current source of an RC circuit, so here I am going to take only voltage source as an example, is suddenly applied. So this is called as excitation. Okay. So the input is called as excitation, the output is called as response. Okay. So whenever the DC source of an RC circuit is suddenly applied, it may be either a voltage source or current source. Okay. And it can be modeled as a step response, step function, right? So that is whenever the t is greater than 0, it will be constant. Okay. And the response is known as step response. Okay. So the input is a step function. Okay. It may be either voltage source or current source, and the response is known as a step response. So consider the circuit. So this is a voltage source, that is a DC source, right? So and R is a resistor, and T, you can see whenever T is equal to 0, the switches get closed. So the Vs is applied to the R and C. Okay. So what happens if T is less than 0? It is not applied to the C. That is switch is open. Okay. So whenever the T is less than 0, you will get that is a DC source is applied to the capacitor. Whenever the T is greater than 0, it is not applied. Sorry, whenever the T is less than 0, it does not applied. Whenever T is greater than 0, the switches get closed. Okay. So this is called as suddenly we are applying the DC source, right? So this I can model it as using a step response. Okay. So instead of Vs, I can multiply with Vs into U of t. Okay. So what does U of t means? U of t is equal to 1 whenever the t is greater than 0. So whenever the t is greater than 0, Vs of U of t is equal to Vs. Okay. So it is applied to the C. Whenever t is less than 0, it is short circuited. So the DC source is not applied to the capacitor. So I can model the previous circuit as without switch. I can replace it by this circuit diagram. Okay. So this is how the step input does. Okay. So U of t, the magnitude value is 1. Okay. Whenever t is less than 0, it is 0. Whenever t is greater than 0, it is 1. Okay. So I can term this one as IA and this current as IB. Okay. So I can write IA plus IB is equal to 0, right? So what is IA? IA is equal to the voltage, that is V minus Vs of U of t divided by R, plus what is IB? IB is equal to, I can write it as the current through the capacitance C into dV by dt. That is equal to 0. Okay. So I can write V minus, so you have to bring the voltage at one point. Okay, so V minus Vs into U of t divided by RC, that is equal to minus dV by dt. Okay, so U of t, we are taking considering t is greater than 0, so U of t is equal to 1. So I can write Vs minus V divided by RC, that is equal to dV by dt. Okay, so now I can bring dt RC is equal to dV by Vs minus V. So now I can integrate this one from 0 to t dt divided by RC, that is equal to V naught. V naught is the initial voltage of capacitance, that is V of t dV by Vs minus V. So V naught is the initial voltage across the capacitance. Okay, so I can write it as if I integrate dt, I will get t as it is from 0 to t, and I can write ln of Vs minus V. Okay, and I can also apply the limits. Okay, so ln Vs minus V limits is V naught to V of t. So if initial voltage across the capacitance is 0, you can term it as 0. Okay, otherwise here the initial voltage of the capacitance is V naught. Okay, so I can write if I substitute the value of t, I will get t divided by RC, right? If I substitute 0, I will get 0. Likewise here also if I substitute what is ln of ln x minus ln y, I can write it as ln x by y. So similar way I can substitute this value and I can write it like this. Okay, so ln Vs, so I have to substitute it for V. Okay, Vt minus ln Vs minus V naught. Okay, so this I can write it as I have already told you the formula. So T divided by RC is equal to ln Vs minus Vt divided by Vs minus V naught. Okay, so I can write taking the exponential on both sides in order to eliminate this ln. Okay, so if I take exponential, e power t divided by RC is equal to Vs minus V naught, and so if I take e power minus t divided by RC, that is equal to Vt minus Vs divided by V naught minus Vs. Vt to Vs minus can bring it outside, so plus V naught minus Vs e power minus t divided by tau. So V of t is nothing but a complete response. Okay, so Vs is nothing but steady state response. Okay, and V naught minus Vs into e power minus t divided by tau is nothing but transient response. So steady state response means it is a permanent one, and permanent state. Okay, transient response means it is a temporary state. Okay, why it is temporary state means it is having e power minus t divided by tau. So at infinity, t is equal to infinity, it goes to 0. And therefore it is remain as temporary, and steady state response, you see, it is Vs. So Vs is always present, right, for a long time. So the steady state response is the behavior of the circuit that has been for a long time, right? After the excitation, that is input Vs, right? After an external excitation is applied. Okay, so here you can see Vs is my excitation. Okay, so what is next one? It's a transient response, which I have already discussed. So let us discuss the definition for transient response. It is the circuit temporary response. This is acute temporary response that will die out, right, with time. So when t is equal to infinity, it will goes to 0. That is what. So it was nothing but a acute temporary response. Okay. So next I can write V of t is equal to, again I am writing the same formula. Okay. So now I can write this complete response is equal to natural response plus forced response. So natural response is stored energy, and forced response is the independent source. So stored energy means V not only percent Vs is equal to 0. So if Vs 0 means V of t becomes V naught into e power minus t divided by tau, and forced response means you have only independent source, right? So independent source means that is nothing but Vs. So only the independent source, that is DC source, right? So if that one is present means V naught becomes 0. So if V naught is 0 means I will get Vs into 1 minus e power minus t divided by tau, right? So if I add both the equation, I will get the value as the same, right? So so you can add these two functions, you will get this answer. Okay, the same answer. So you can see natural response is nothing but whenever only the initial condition is considered, and it is a source free one, right? Whenever the forced response means we are giving an external DC supply, and we are considering the initial voltage is equal to 0. So I can write V of t is equal to V infinity plus V naught minus V infinity e power minus t divided by tau at t is 0 plus, that is t is greater than 0. Okay, this is the actual formula. Okay, so V of t is equal to Vs into 1 minus e power minus t divided by tau. That is when V naught is equal to 0. That is initial voltage at the across the capacitor is 0. Okay, so this is how the equation is. So that is so how the graph will look like if I plot for V of t in y-axis and t at x-axis. At t is equal to 0, I will get answer as Vs, and you can see at and it is slowly, sorry, at V is t is equal to 0, it is 0, and whenever t is equal to infinity, it goes to Vs. So this is how it is. Okay, so if I want to find the I of t, I can write I of t is equal to c dv by dt. So if I differentiate the VT value, previous value, Vs into and I will get 1 if I differentiate into 0 minus e power minus t divided by tau into minus 1 divided by tau. Okay, so what is tau? Tau is nothing but RC. So you substitute RC, so CC will get cancelled out. So Vs divided by R into e power minus t divided by tau. So if I plot it for I of t, okay, there is a current flowing through the capacitance. So if I plot this one at t is equal to 0, you will get I of t value is Vs by R, right? And at t is equal to infinity, you will get 0. So you will get the equation graph like this. Okay. So it is an exponentially decaying function. So let us discuss on problem based on this step response of RC circuit. This is a problem. They are asking to find the value of I and V. Okay. So at t less than 0. At t less than 0, what is the condition you have to take? The capacitor must be open circuited. At t is equal to 0, you can see the switch is open. So now we have to consider the switch is closed, and u of t which is less than 0, it is 0. So it is short circuited. So so across the capacitance only we need to find the value of V at 0, right? Since the capacitance is open circuited. Okay. Now the switch is closed because it is less than 0. Okay. So it is closed and it is connected to 10 volt source. Okay. So what is the voltage across the 20 volt? Since R and 10 and 20 are in parallel, I can write V of 0 is equal to V of 0 plus that is equal to 10 volt, right? Because across the 20 volt you have 10 volt. And what is I? I is equal to, that is also 10 volt, like 10 minus 10 divided by 10. Because 10 volt is across the 10 ohm resistor. So, okay. So I can write I is equal to minus 1 amps. Okay. Yeah. So now at t greater than 0. At t greater than 0, the switch is open circuited and u of t is becomes 1, right? So you will get 30 and it is connected to 10 and 20 ohm resistor. And again I am going to open circuit this capacitor in order to find the value of V of infinity. Okay. So it should be V infinity, and here the circuit is open. So this is how it is. So the V of infinity, Vc of infinity is equal to 20 into 30 divided by 30, right? According to the voltage divider rule. So that is equal to 20 volt. So you substitute in this equation, right? V of t is equal to V infinity plus V naught minus V of infinity e power minus t divided by tau. So V of infinity is 20 and V of 0 is 10, which we have already find out, and tau is equal to R equivalent into C equivalent. So to find R equivalent, you have to open circuit, you have to find R equivalent across the capacitance, right? And the source, the voltage source must be short circuited. So 10 and 20 volt are in 10 and 20 ohms are in parallel. So R equivalent is equal to 10 into 20 divided by 30, that is equal to 20 divided by 3. So you substitute this equation, and C value we already know that is 1 divided by 4, right? So you can see this is 1 divided by 4. So R equivalent and C equivalent also we already find out. So I can write v of t is equal to 20 minus 10 into e power minus 3t divided by 5 at t is greater than 0. To find I, so what is I? You see the equation, this is I. Okay, so so I can write according to the 30 minus this is nothing but now it is v of t, right? So the voltage across 20 ohm is v of t. So I can write 30 minus v of t divided by 10 is equal to I, right? So you know the from the nodal equation, right? 20 minus v of t. So v of t is nothing but we already know the value of v of t, right? So from the previous equation, so I substitute that value. Okay, so I can write it as I is equal to 30 minus 20 plus 10 e power minus 3 by 5 t divided by 10. So I can write I is equal to 10 plus 10 e power minus 3 by 5 is 0.6, right, divided by 10. So that is equal to 1 plus e power minus 0.6 t. This is your I, which is used to measure in terms of amps and t value is greater than 0. Okay. So I hope you have understood this one. Let us discuss another problem. Okay, you take this one as a reference problem. Okay, I'm not going to solve this problem. So, but I give you the answer for I of t. You find the value of v of t, and you can comment the answer in the comment section. Okay. So, and you can also, if you have any doubt, you'll ask the doubt in the comment section. Okay, so this is a circuit. I need to find the value of I and V, and I value and V value is given. Okay, I value answer I'm giving. You find the values for V. Okay.